Okay, let's jump right into this explainable. We're looking at the launch of DeepSeek V4 today, and while this is a release that's fundamentally changing the economics of artificial intelligence as we know it, it's a real game changer. So is the era of expensive AI over? That's the million-dollar question, right? Or, well, considering the pricing we're about to see, maybe it's the fraction of a cent question. A brand new model just hit the market, and it's promising top-tier, frontier-level performance for next to nothing. It's literally making developers and enterprise tech teams completely rethink their entire infrastructure. Here's the kicker. DeepSeek V4 just launched with a massive 1 million token context window by default. And incredibly, it operates at roughly 1/10, the price of its Western competitor Claude Opus. I mean, that is a staggering drop in cost. It opens up entirely new use cases for AI that just weren't financially viable before. For today's agenda, we'll cover, is expensive AI over? Then we'll look at the specs of Pro versus Flash, the Claude killer benchmarks, their non-NVIDIA secret sauce, some real-world developer feedback, and finally, self-hosting a frontier model. Section 1. Is expensive AI over? The economics of frontier models. Let's start with the sheer scale of this disruption, and just look at the actual API pricing numbers, because they are wild. Notice the stark contrast here. Let's put this into perspective. Say you're running 10 million output tokens. On Anthropic's Claude Opus 4.6, that's going to cost you about $250. But that exact same workload on DeepSeek's V4 Flash model, just $2.80. Even their flagship V4 Pro model sits at only $3.48 per million tokens. You know, this isn't just some slight discount. It is a complete commoditization of frontier-level reasoning. Section 2. Pro versus Flash, the specs. Let's take a look under the hood of V4 to see exactly how it's structured to allow for such an aggressive pricing strategy without sacrificing the actual quality. So, DeepSeek released two open-weight options, and they're both under a highly permissive MIT license. First up, we have the massive 1.6 trillion parameter Pro model, which is built for heavy, complex reasoning. Then there's the hyper-efficient Flash model, coming in at 284 billion parameters, designed specifically for speed and cost-sensitive tasks. Now, both of these use a mixture of experts architecture. What does that mean? Well, even though the Pro model has 1.6 trillion total parameters, it actually only activates 49 billion of them for any single token. And that right there is exactly how they keep the inference compute cost so remarkably low, all while maintaining that incredible 1 million token context window. Section 3, the Claude killer benchmarks, analyzing the coding performance. Look, cheap pricing means absolutely nothing if the model isn't smart, right? So let's move over to the data and see the case it builds. This brilliantly illustrates what is truly a David versus Goliath moment. In complex coding tasks like the live code bench evaluation, the open-weight V4 Pro actually edges out Anthropic's flagship Claude Opus 4.6, hitting a massive 93.5%. It also leads on Terminal Bench, an agentic coding benchmark. Now, just to be perfectly impartial here, the sources do note that DeepSeek V4 still trails slightly behind models like GPT 5.4 and Claude when it comes to general world knowledge and factual recall. But for autonomous software engineering and repository-level coding, it is competing directly at the bleeding edge. Section 4. The secret sauce. No NVIDIA. Architectural innovations. Let's explore how a Chinese lab managed to train a 1.6 trillion parameter model so efficiently, especially when they're facing strict US export restrictions on top-tier computing hardware. The answer lies in their engineering. To avoid the massive quadratic compute cost that normally comes with a million token context, they actually invented a hybrid attention system. Think of it like trying to read an entire encyclopedia, but instead of reading every single word on every single page, you're instantly filtering out everything except the absolute most crucial keywords you need. So the absolutely crucial point here is that by combining this memory trick with something called MHC, which basically stabilizes the signal as the model scales up, they achieved a massive 73% drop in compute costs, along with a 90% reduction in KV cache memory burden. And honestly, perhaps most significantly from a geopolitical and supply chain perspective, they trained this entire frontier model using Huawei and Ascend 950 PR chips. No way, right? They achieved all of this without touching a single NVIDIA GPU. It really proves that architectural innovation can completely offset hardware limitations. Section 5. Real-world developer feedback. The good, the bad, and the verboten. Lab benchmarks don't always reflect reality. We know that. So let's look impartially at what developers are actually out in the wild. Early community feedback definitely highlights the model's strengths. Users are finding that the Pro model is exceptionally talented at grasping complex repositories and accelerating autonomous software engineering. As one user noted, for tasks like scientific coding, it's performing superbly and consistently catching bugs, flaws, and gaps that other models might just entirely miss. But okay, it's not perfect. It's important we look at the limitations too. Users also note that when the model simply lacks an answer, it can suffer from pretty high hallucination rates. Furthermore, it has a sort of chatty verbosity. Basically, it likes to talk a lot. This over-explaining can inadvertently slow down automated agent workflows and actually consume more output tokens than strictly necessary. So for sure, it requires some really good prompting to keep it focused. Section 6. Self-hosting a frontier model, bringing AI on premises. Let's bring this all back home. What does a highly efficient, MIT-licensed open-weight model actually mean for you as a developer, a researcher, or a business leader? Well, it means you can take it offline and run it yourself. Because of its sparse architecture, you don't need some massive multi-million-dollar data center to run this thing. You can actively self-host a compressed, quantized version of the 1.6 trillion parameter Pro model on standard consumer graphics cards. When we are talking about hardware you can go buy at a local electronics store today, like dual RTX 4090s or a single RTX 5090. This completely changes the game for data privacy and on-premises enterprise AI. So, as you think about how to deploy AI in your own projects going forward, ask yourself this: are we witnessing the permanent end of premium AI pricing? With DeepSeek V4 proving that frontier-level coding and million-token context can be delivered for literally pennies, what on earth will the closed-source labs do next to justify their massive costs? It's a fascinating shift, and one that gives us, the users, an incredible amount of power and accessibility. Thanks for joining me for this explainer, and keep questioning the limits of what's possible.